acids and bases have got a whole lot of different definitions or terminologies that you need to know. So let's look at those. If you've got a concentrated acid, it means, or concentrated base, it means you've got a large number of moles that have been added to the solution. If it's dilute, obviously the opposite. Well, not so obviously, because you're about to find out that strong doesn't mean the same as concentrated. But anyway, dilute is the opposite of concentrated. There are few moles that have been put into the solution. A strong acid, however, is a virtue of the actual acid's nature, and it has got to do with the equilibrium position. So when the acid dissociates, when the base dissociates or the acid ionizes, your equilibrium will lie far to the right. In other words, it's very effective at dissociating or ionizing. Strong acids ionize almost completely in aqueous solutions, whilst weak acids only partially ionize. Strong bases dissociate almost completely in aqueous solutions, whilst weak bases dissociate partially in aqueous solutions. Now, how do we know which is which? We basically have to learn it. And I'll tell you which ones to learn in a second. In the meantime, let's just remind ourselves what the difference is between dissociation and ionization. Dissociation is when an ionic substance, could be NaCl, or if we're looking at bases more specifically, it could be NaOH, or perhaps KOH, or perhaps Mg(OH2), magnesium hydroxide. Any of those, they could break up into their constituent ions, for example, Na plus and Cl minus. So when they get popped into water and then they become aqueous, both of them, that means they're dissolved in a water solution. Ionization is slightly different, and this happens with acids. It's when polar covalently bonded molecules, form new ions when they get placed in water. So in other words, the water actually becomes part of the ion. So HCl goes into water and you get this H3O plus ion, which is the hydronium ion, sometimes called the oxonium ion. Very inconvenient that it's got so many names, but there it is. And you actually create new ions, and most of the acids will do that. They will form this H3O plus ion from a hydrogen that was previously covalently bonded. Then you've got ammonia and water. This is an example of a base doing the same thing. When ammonia goes into water, you get the ammonium ion. And what has happened is that the water has donated a proton to the ammonia, and therefore that is a proton donor, and that's an acid. And then the ammonia acts as base. It accepts that proton, and then you create the hydroxide or hydroxyl group, and that is the OH minus. What's very important with ionization is that you create these new ions. Substances which ionize or dissociate will always be able to conduct electricity because there's positively and negatively charged particles. And that is known as an electrolyte, a solution that can conduct electricity. The more ions there are in solution, the better the conductivity. So if I've got a strong acid, I will get lots of ions and it will be very good at conducting. If I have got a weak acid or base, the equilibrium will lie to the left, and I will have very few ions, and it will not be a good conductor of electricity. Both ionization and dissociation are going to be reversible reactions, and therefore when we ask questions, we can always bring the whole of equilibrium into questions around acids and bases. So if we're looking at the concept of strength and weakness, when equilibrium lies far to the left, very few ions are made, so we call that a weak electrolyte, and that is a weak acid or base. However, if the equilibrium lies to the right, then we have lots of ions being formed, and that is a strong electrolyte. It will have a high Ka value, which is like the same as a high Kc value, and if you've got a weak acid or base, it will have a low Kc value or a low Ka value. You need to know what a strong acid is. Hydrochloric acid, sulfuric acid, and nitric acids are all strong. Strong bases are the group 1 hydroxides. In other words, sodium hydroxide and potassium hydroxide and lithium hydroxide are all strong bases. Your weak acids are things like hydrofluoric, ethanoic, carbonic, sulfurous, nitrous, phosphoric, and citric acids. Their equilibriums all lie to the left. And weak bases are things like magnesium hydroxide, calcium hydroxide, aluminium hydroxide, and ammonium hydroxide. And all carbonates are actually weak bases as well. Remember that covalently bonded liquids and covalently bonded substances do not ionize. If they do not ionize, they do not conduct electricity. It's only if they ionize in the solution that they're going to be able to conduct electricity. Water conducts electricity very, very slightly. Water is a covalent bond, and in order to form ions, it has to self-ionize. In other words, it makes ions out of itself, and this process is known as auto, on its own, protolysis, exchange of protons, where some of the water acts as an acid and some acts as a base. So, the water breaks up into H3O plus ions and OH minus ions. This is autoionization or autoprotolysis. And you can get the Kc value of this because, okay, this is a pure liquid. So Kc is the concentration of the products raised to the power of them over the concentration of the reactants, which is 1 because of the fact that it is pure liquid. And that Kc value is 1 times 10 to the negative 14. Remember that a small Kc value means that the equilibrium actually lies far to the left. This is very small, it's times 10 to the negative 14. When we're measuring pH, we look at the H3O plus concentration in the water context. It is a measure of the H3O plus concentration. We don't have to be able to calculate it, but you need to be aware of the fact that pH is the measure of the hydronium ion concentration. So what is the pH scale? It's a continuous scale. You don't only get a pH of 4 or 5 or 6. You can get 6.3, 3.27, 10.86. Anything along there can be the pH. Remember, because of the times 10 to the negative 14, 14 is the greatest number because you actually do something called the negative log of the pH, of the H3O plus concentration. But the point is, it's a scale up to 14, which links to that 1 times 10 to the negative 14, which is the Kc value or the Kw value of water. We know that indicators are things that will change color in the presence of different pHs, and this is the way that you can determine the approximate pH using an indicator. You can also use something known as a pH meter, which you pop into the solution and it will tell you exactly what the pH is. Universal indicator is an indicator that has a range of colors from red all the way through to purple that have the actual pH of the solution, with green being neutral. These you need to know. Your colors in an acid of litmus: red, phenolphthalein is clear, bromothiamyl blue, yellow, and methyl red, red, whilst in a base they are blue, pink, blue, and yellow respectively. Remember, I said in an earlier thing that litmus will change color in a neutral environment, whilst phenolphthalein is good for a basic endpoint, and bromothiamyl blue is good for a neutral endpoint, and methyl red is good for an acidic endpoint. So those are your appropriate indicators to use under different conditions, depending on whether you've got strong acids and weak bases or weak acids and strong bases.